Hello everyone. As I promised last week, my plan for today is to solve a few examples, and these examples are going to cover most of the concepts that we have seen so far regarding limits, and then basically using these examples and solving these examples will prepare us for exams in future. Okay, let's start with the first one. The problem says if the limit of 2x minus 1 over x squared plus ax plus b is undefined, find a and b. So the problem statement is giving us some sort of information. The first thing is it is saying it is undefined. So the problem is saying that this limit is undefined, and we have to think when a limit is undefined. Basically, one case is we have a number over 0, and therefore that is going to be undefined. For example, we have 1 over 0, which is undefined. Okay, and now if we look at this problem, and similar to any other limit problems, the first step is to plug in the value that we are approaching to it, and here we are approaching to 2. So if we look at the problem, we have the limit of x approaching to 2, 2x minus 5 over x squared plus ax plus b, and if we plug in 2 instead of x, what we will have is going to be 2 times 2 minus 5 over 4 plus a times 2 plus b, and the answer at the end is going to be minus 1 over 4 plus a times 2 plus b. Okay, and based on what I discussed, that we have to look for minus 1 over 0. So the bottom part, basically the denominator, should be 0. Therefore we can say, okay, in order to have this limit undefined, we should have x squared plus ax plus b equal to 0 when I plug in x equal to 2n. So it means that x equal to is basically the root of this function. Therefore we can convert this algebraic formulation into the form of x minus 2 squared, and it means, okay, now if we plug in 2 in there, the answer on the bottom is going to be 0. And if we expand it, we'd see it's going to be x squared minus 4x plus 4. Yeah. Now if we look at x squared minus 4x plus 4, and what we have on the bottom, on the denominator, which is x squared plus ax plus b, and from there we see a is actually minus 4 and b is actually 4. So if the problem asks for example, a plus b, the answer is going to be 0. Okay, as you have seen, for solving this problem, we just looked at one simple definition related to undefined limits, and from there we started looking at what we have on the bottom of this function and how we can use some sort of simplification in order to get the final answer for this problem. Okay, let's look at the second problem, in which we have a function in the form of ax minus cube root of x squared minus 1 over 4x to the power of n minus 12, and it says if the limit of f of x when x is approaching to infinity is equal to 1 over 6, find a and n. So we are looking for this a and this n in here. Okay, as you remember, whenever we are dealing with a rational function, basically we have 3 different cases. One case is actually on the numerator we have the highest order, and the highest order of the numerator is bigger than the highest order of the denominator. The other case is the top part and the bottom part, the highest order are the same, and at the end the coefficient of basically the highest order is going to be the answer. And the third case is when the denominator has the highest order, and the highest order of the denominator is bigger than the highest order of the numerator. Okay, so from there, if we look, basically what we have is a form of answer when x, let's say, the limit of f of x when x is approaching to infinity is 1 over 6. So if you look at the video that we had regarding this type of functions, basically when the highest order of the top part is bigger than the highest order of the bottom part, the answer is infinity. The other case was when the highest order of the bottom part is bigger than the highest order of the top part, the answer is 0. And there is only one case in which we have sort of the answer in the form of a number, like in here 1 over 6, and that case is when the highest order of the top function or the numerator is the same as the highest order of the denominator. And if we look in here, in order to satisfy that condition, we have to say, okay, the highest order of the top is basically in here. If we look, this is 2 over 3, but this one is x, so the highest order in there is ax, so the x to the power of 1 is the highest order. So this function can be written in the form of basically ax. And if we look on the bottom, so 12 is a number, so there is no sort of variable multiplied with 12, so the only thing that we have in here is x, and x is going to be on the bottom, so the highest order of the bottom is going to be 4x to the power of n. And based on those conditions that I discussed, the highest order of the top and the bottom should be the same in order to get a number like 1 over 6 when x is approaching to infinity. So this is 1 over 6. It means that, okay, this n is the same as whatever we have on top as the power, so the answer for n is going to be 1. And if we look at the other term in here, we have a over 4, which is going to be equal to 1 over 6, and based on what I discussed, the coefficient of the highest order on the top and the bottom is going to be the final answer. So a over 4 is actually 1 over 6, and this would result in a equals to 4 over 6, therefore a is 2 over 3. Okay, this is the answer. What we did again was the sort of use of the conditions that we have for the rational function. We have looked at different forms that are possible for a rational function when x is approaching to infinity, and based on those conditions we notice, okay, for this problem what we have is the second condition when the highest order of the top and the highest order of the bottom are the same, and based on that we solve the problem. If you guys are interested to see how we can solve rational function, and if you need to review, you can watch our previous video on actually limits of functions at infinity. We focus on the rational function. Okay, let's look at the third example. This one is very interesting. We have 1 minus tan squared of x over s square root of 1 plus sine 2x, and x is approaching to 3 pi, the left side over 4. Okay, so the first step for solving of this problem, again similar to any other limit problem, is to plug in the thing that we have and the thing that we are approaching to it. So what we are approaching in here is x to 3 pi left side over 4. So if we basically plug in now this number in here, the answer is going to be in the form of 1 minus tan squared 3 pi over 4, and on the bottom we will have 1 over sine 2 3 pi over 4. So this is going to be the answer. On the top is going to be 1 minus 1, and the bottom would result in again in the same thing, 1 minus 1. Therefore it is 0 over 0. Okay, now we have to use some sort of algebraic simplification in order to solve this problem. So the first thing, okay, let's see what we have in here. We have 1 plus sine 2x, okay, and we have to think how we can actually simplify it. 1 in the form of trigonometric function is actually sine squared x plus cos squared x, and for sine 2x, what sort of simplification we can write? It is actually 2 sine x cos x. Okay, now this is very beautiful because we have sine squared x plus cos squared x plus 2 sine x times cos x, which means we have a squared plus b squared plus 2 times a times b. Okay, so from here what we can get is actually at the end is a sort of a plus b squared, and therefore we can write it is sine x plus cos x squared. Okay, so now instead of 1 plus sine 2x, we can write actually sine x plus cos x squared. So let me rewrite that limit. So it's going to be, let me use another color. So I'm going to use blue color. So it's going to be the limit of 1 minus, instead of tan squared x, I'm going to write sine 2 actually x over cos squared x, and on the bottom I'm going to write the sine x plus cos x squared, and x is approaching to 3 pi over 4 from the left side. Okay, now we have to see, we have sine x plus cos x squared, so it's in power of 2 and it is inside the square root. So we can take it out of that square root and we can rewrite it in the form of, basically, let me rewrite it in that form, cos squared, and just simplifying the top part and getting the common denominator. Basically it's going to be minus sine 2x over cos squared x over, and on the bottom, because I'm taking the power, that function out of the square root, so we need an absolute sign. So it's going to be sine x, sorry, I just forgot the limit. So it's going to be the limit, and then x is approaching to 3 pi from left side over 4. 3 pi over 4 from the left side. So what we have in here, it's going to be sine of x plus cos x. Okay, and it's time again to plug in the value. So if we look at the sine x, when we are actually in the second region of that specific circle related to the sine and cos x, you'll see, okay, this function, the sine x, is basically decreasing, okay, and cos x is a function which is increasing. And if you plug in there, it's going to be the square root of 2 over 2 positive minus a square root of 2 over 2 positive. And as I said, the sine x is decreasing, so it is getting less when it actually getting to the value of 3 pi over 4. And the other function, cos x, is increasing. Basically, when it approaches to 3 pi over 4, the value is going to be bigger, which means that this square root of 2 over 2 is actually bigger than this one, which results in a positive value for whatever we have inside this absolute sign. So we can say, okay, at the end, this is going to make a positive sine x plus cos x actually. So this is going to be in the form of cos squared x minus sine squared x, and then on the bottom we will have let me say we have cos squared x times sine x, so we can actually now say it is sine x plus cos x. Okay, we can actually expand whatever we have on top, so we can write it as, let me rewrite it here, x approaching to 3 pi over 4 from the left side. Now we can say, okay, this is actually the limit of x approaching to the limit of x is approaching to 3 pi over 4 from the left side, and we can actually say it is cos of x minus sine of x times cos of x plus sine of x over cos squared x sine of x plus cos of x. And if we look now, this sine of x plus cos of x can be actually cancelled from the top part, and then we have at the end, let me cancel this out. So we will have the limit of cos x minus sine x over cos squared x, and again x is approaching to 3 pi left side over 4. Okay, so now if we plug in 3 pi over 4 instead of x in that function, this will generate actually minus a square root of 2 over 2, because cos x is negative over there and sine x is positive, so it's going to be square root of 2 over 2 over a square root of 2 over 2 squared. So this will generate at the end, this will generate minus square root of 2 over 1 over 2, and the answer of this problem is going to be minus 2 times a square root of 2. As you have seen, the procedure of solving of this problem was a bit long, and what we did first, we looked what sort of trigonometric property we can use. So in the denominator of the function we saw, okay, we have 1 plus sine 2x, and okay, what is 1 in the form of trigonometric function? 1 is actually sine squared x plus cos squared x. Okay, I just plug in there in here, and then okay, what is sine 2x? Okay, we can write it in the form of 2 sine x times cos x, and from there, okay, we can say basically it is a plus b squared if we assume sine x is a, cos x is b, and then 2 sine x cos x is making 2 times ab. Therefore, what we have is actually a plus b squared, which means we have sine x plus cos x squared. Okay, and then we just plug in that sine x plus cos x squared instead of that function in the limit, and we move forward with some more simplification, and finally we got the answer. So the main point in here is you have to be very comfortable with trigonometric function and with the properties, because sometimes the problem that you will see in the exam are going to be a bit complex, and they're going to combine different forms of properties in trigonometric function. Okay, let's look at the very last problem that I have for today. The problem is saying, okay, find a such that the limit of following function exists when x is approaching to 2. Okay, when the limit exists. Okay, when we are approaching from the left side, when we are approaching from the actually right side, we are getting the same number for that limit. It means that the limit exists, and we have to do this actually for the problem that we are solving. Okay, if we look, okay, for the function, we have in a sort of piecewise function. When x is bigger than 2, the function is 3 times x minus 6 over x minus square root of x plus 2. And for the other actual side, when x is less than or equal to 2, we have ax minus 1, which means that, okay, when you're approaching from the right side to positive, basically, we have to use this function, and when we are approaching from to negative, the left side, we have to use ax minus 1. Okay, let's do it. For the top part, we have the limit of x approaching from the positive, from the right side, at 3x minus 6 over x minus square root of x plus 2. Okay, if we plug in similar to any other problem, we are approaching to 2 from right side, we have to plug in that value inside the function, so it's going to be 0 over 0. So the answer is going to be 0, 0, which is an indeterminate form, and you know how we can solve this problem. If you don't remember, you can watch our previous videos on indeterminate forms, in which we discussed how we can solve a rational function in which there is a term like a square root. Okay, and let's actually have a quick review on it. When we have this sort of function, the first thing that we have to do is multiplying both numerator and denominator with the conjugate form of the term needed to be multiplied. Okay, in here we have x minus square root of x plus 2, and we have to multiply with the conjugate, which is actually x plus square root of actually x plus 2. And I'm going to do that step here. Okay, let me write it in the form of the limit of x approaching to 2 from the right side, and it's going to be 3x minus 6 over x minus square root of x plus 2, and this is going to be multiplied by x plus square root of x plus 2 over x plus square root of x plus 2, which results in, okay, it's going to be 3x minus 6, and it's going to be x plus square root of x plus 2, and on the bottom we will have, okay, what we have in here, it's going to be x, let me see, x minus actually x squared minus x plus 2, which results in, at the end, I'm going to actually factor 3, which is going to be x minus 2, and then multiplied with, don't forget the limit sign, I always forget to put the limit, so it's going to be the limit x to positive, so it's going to be 3 times x minus 2, x plus s square root of x plus 2 over, and at the bottom we have x squared minus x minus 2. Yeah, so now what we have in here is x squared minus x minus 2. We can write it as x plus 1 x minus 2 actually, yeah. So we can convert it into the form of 3x minus 2 square root of, let me actually cancel this out, it's going to be x, the limit x is approaching 2 positive, the limit again here, x approaching to 2 positive, and this is going to be 3x minus 2, and then we have x plus square root of x plus 2 over what we have. It is going to be x minus 2, x plus 1. This x minus 2 will be cancelled. Now we can plug in 2 instead of x, which results in 3 times 2 plus the square root of 4 over 2 plus 1, which is going to be 3. So this 3 is going to be cancelled, and the answer over here is going to be 4. Okay, when x is approaching to 2 from right side, the answer is 4, which means that when x is approaching from the left side, the answer should be the same. Therefore, we can say, okay, the limit of ax minus 1, let me write with another color. I'm going to use the red. So the limit when x is approaching to 2 from the left side is ax minus 1, and it should be, in order to actually have the limit in the form that we can say this limit exists, we have to say this should be equal to 4. Now let's plug in 2 instead of x. It's going to be 2 times 2 minus 1, sorry, a times 2. A times 2 minus 1 equals to 4. So now what we have is, we have ax minus 1, and the answer at the end is going to be 2a minus 2a equals to 5. So the answer is 5 over 2. Okay, you have seen what we did was just looking at the meaning of the limit when the limit exists, which means that, okay, if we are moving from right or we are moving from left to that specific value that we are approaching, we should get the same answer, and we have used that definition. Thank you very much for watching this video. If you still have difficulty with solving these types of problems, you need to watch our previous videos on the different forms of limits, and actually different forms of indeterminate limits, and then you can watch our other videos on solving different approaches for solving indeterminate limits. And then after that, I would say you should be fine for your exams if you do a bit practice.